Good afternoon, everyone. I hope you've had a great first half of the first day of the conference so far. Let's try to keep this up. So today I'm going to talk to you about the future of .NET desktop development. And of course, for now, this means .NET Core 3 and what it brings to the table for WPF and WinForms. Now, I personally find it very exciting and a bit strange that I'm here in 2019 at a conference talking about WinForms. But here we are. So, first of all, it's very nice to meet you all. My name is Nico. I live in Belgium, where I'm an application architect at a consulting company called Dolmo. I've been an MVP in Windows development since 2014, and we also run our own user group in Belgium, mostly focused on mobile development, but all with a Microsoft twist to it. So that's the address of my blog, my Twitter, and my email. Should you want to reach me for some reason, if you have some questions, some remarks, the easiest way is to reach out on Twitter. I'm mostly active there. So feel free. Now, before we dive into everything that's new in .NET Core, let's start with the why. Why this talk? Why is Microsoft investing again in desktop development? So, quick show of hands. Who's been doing WinForms lately? That's quite a lot of people. How about WPF? Oh, wow, that's impressive. I think there are more WPF developers here than we have in our company. That's amazing. So, how much of this WinForms or WPF work is new development? And new development, let's say, projects started in the last 2 years. New projects. Anyone? Quite a few, that's nice. And all the others are maintenance? Bug fixing, keeping the lights on, everything? Cool. Well, as you can see, there are a lot of you still doing desktop development. So that's the reason we're all here. You're all in the right place. And Microsoft released some numbers. Last year at Ignite in 2018, they told us that nearly 2.5 million developers are doing WinForms or WPF work in Visual Studio on a monthly basis. That's 2.5 million developers making money by writing or maintaining desktop applications. That's a lot of people, it's a lot of developers. Also, and this is maybe a bit less important for the major part of the talk, but at Build last week, they announced that 800 or over 800 million devices are currently running Windows 10. And this has a small impact on a small part of this talk, but mostly doesn't really matter. Just wanted to mention it. So, .NET Core. Everyone's heard of .NET Core, I presume? So .NET Core is open source cross-platform framework by Microsoft. It's kind of like a blank slate for .NET. They started over, completely out in the open. Source code is out there on GitHub with all the issues and pull requests that you want. But for so far, it's been mostly focused on web and cloud development. There was no desktop story in .NET Core. We were stuck with good old full .NET framework. Now, with .NET Core 3, they are moving the platform forward by adding support for desktop, IoT, and AI/machine learning. One problem there is that one of the premises of .NET Core is that it's cross-platform. Now, WPF lives on top of DirectX. WinForms lives on top of GDI+. Two technologies that are really deeply embedded into Windows. It's not easy to take those out and, let's say, for example, make XAML or WPF run on Linux or Mac. It's just not technically possible. So in order to keep on track with what .NET Core stands for, they introduced the concepts of desktop packs. And a desktop pack is kind of like an add-on that brings all the WinForms WPF libraries over to .NET Core. Meaning that you do have a .NET Core solution with all the modern stuff that .NET Core brings to the table, but you are restricted to Windows at that point in time. So what does .NET Core 3 bring to the table? First of all, we get command line. we can start a new WPF, new WinForms project from a simple command line command. We can compile them from there, we can run the applications from there, we can publish them, all using command line. We can use XAML islands. Who has heard of XAML islands? Few people, not too many. XAML islands is actually quite impressive. What this does is it allows us to take UWP controls written in UWP XAML, take those out and use them in WinForms and in WPF. And not only the inbox controls, but also completely custom written UWP controls, for example, by you. You can write a control in UWP, take it out, put it into a WinForm, and it works. We get high DPI fixes for WinForms. This is a major one. WinForms and high DPI screens, they don't match. If you scale your WinForms project, you might run into some issues. They are fixing this or have fixed it, depending on what the problem is. We get full access to the Windows 10 APIs. So UWP, very modern framework, all these fancy APIs, easy to use, very modernized. For now, they were not usable from WinForms. By bringing your WinForms application to .NET Core 3, we can call into these APIs. Let's say, for example, notifications. We all know the Action Center in Windows 10. From your Windows or WPF app, WinForms or WPF app, you can push notifications into the Action Center and add custom commands to it and everything. Another really important one is self-contained applications. And I really like this one, although it does come with a catch. So what's a self-contained application? You can publish your, let's say, for example, WinForms app, and embed .NET Core 3 into the application itself, so that the machines that you run your application on do not have to have .NET Core 3 installed. It just runs because all the bits are included with your application. That's pretty impressive. It does increase your application size. Obviously, you ship the full framework with it. And the downside on this is that you as a developer are responsible for keeping that embedded version up to date. So let's say you ship the version that is available today. Microsoft finds some security issues with that version, fixes them, publishes a new minor version. It's up to you to embed that minor version into your application, because that still runs the version that has the security flaws. So that's a bit of a downside. A major upside is that you can run applications using different versions of .NET Core side by side. They won't interfere with each other, because the framework is embedded inside the application itself. Pretty powerful stuff. So how about normal .NET framework applications, full .NET? Are they gone? They are not, at least not right now. Microsoft is releasing .NET Framework 4.8, promising long-term support for this version of the framework. So you can update your full .NET Framework applications to Framework 4.8 and have long-term security updates and everything that you want. Now, whenever you're ready to move to .NET Core 3, it's out there, it's waiting for you. Now, should you just jump in, take every application that you have and just port it over to .NET Core 3? In my opinion, and this is my personal opinion, I don't think so. If it's an application that's in active development, and active development as in you're adding new features on a regular basis, then you can think about porting over, and it might actually be a good idea. If you're starting a new project, there's no doubt about it, start in .NET Core. There's no reason anymore to start with a full .NET Framework application. Now, if you have an application that you're only doing maintenance on, it's out there, it's stable, it's feature complete, there's really no reason to put in the extra effort to ship it over, especially since they're promising long-term support with 4.8. So you need to weigh off the consequences, because porting does take a certain effort, and efforts costs money, of course. So you need to look at the effort required and if it's worth it on case by case. Now, what's next? As you all probably know, last week was Build, which was awesome because I could change my slides a week before the conference. But they announced .NET 5 at Build. And .NET 5 is basically .NET Core 4. So they're doing away with the .NET Core name, and they're going back to .NET 5, or to .NET, simply put. Now, .NET 5 will be available across all these. Desktop, web, cloud, IoT, mobile, with Xamarin then. Windows Mobile is not coming back as far as I know. So .NET 5 will be available across the line. Now, how are they doing this? .NET 5 is a single runtime, same capabilities, same APIs, same code across all platforms. But for example, they're making the CLR a drop-in replacement, or at least that's the end goal. If you have a desktop application, it will run on Core CLR, which is the runtime for .NET Core. And if you run that same application on a mobile device using Xamarin, they will take out Core CLR and just drop in the Mono runtime. So they're doing work on both Mono side and .NET Core side to make sure that the runtimes are simple drop-in replacements. They've told me it's a lot of work, so yeah, we'll see how fast it goes. Major upside on this is that you can use Visual Studio for Mac, Visual Studio Code, even on Linux, and even plain old CLI, command line, to develop all these applications. So that's a pretty nice future to look forward to. Enough slides, for now, at least. Let's have a first look at how this works. So, I have a command line. Let's check my version. I'm currently running on .NET version 3.0.100, Preview 5. Preview 5 was released last week at Build. So my demo was completely written on Preview 4. Another thing I could change. It's still in preview, that's important to know. It's not available, or it's not generally available yet. It's a preview. Preview is out in the open. You can download the installer, install it and have a go at it. And now, for example, we can say .NET New. Let's start with a WinForms project. .NET New WinForms. Let it run for a bit. There we go. If I look at the output folder now, I have a WinForms project created by a command line. Now I can say .NET build. Oh, need to specify project file. There we go. It's telling me that I'm using a preview version of .NET, just to make sure that I'm aware. It compiled, and now I can simply call .NET run. If you've played with .NET Core before, you should be familiar with these commands. But here it is, my WinForms application running on .NET Core 3 in all its glory. It's just an empty form, of course. Okay, let's do the same with WPF. Oh, missed the parameter. There we go. So here's my WPF project. Let me open this in Visual Studio real quick. Now I'm running Visual Studio 2019, but the release build. So Visual Studio has 2 rings right now. It has the general release ring and it has the preview. I'm not running the preview, so this is general release. Microsoft does ask you to please run the preview version of Visual Studio if you're doing .NET Core preview stuff, but it's not required. The only thing you need to do if you want to run on the release version is go to your options Check the projects and solutions, .NET Core. You need to check this checkbox. That's all you need to do. From that moment on, the release version of Visual Studio 2019 will just support .NET Core preview versions. So here's my WPF project. I can just run it from Visual Studio as well. There we go. It's the same thing as the WinForms one. If I take a look at the properties, you will notice that I'm running on .NET Core 3. And it's just plain old XAML. Now, one downside of the current state of .NET Core 3 is that we do not have visual editors available, like the WinForms editor, the drag and drop stuff. It's not there yet. Same with WPF. The editors are not yet available. So for now, you have to do everything in code. For XAML, no problem. I can type XAML pretty well, or at least I like to believe that. But for WinForms, that's a bit different. You have to write everything in C#, make sure everything is positioned correctly. There are workarounds, and I'm going to show you one later in the demo. But for now, this is how it is. There's no editor support. They are working on it, and it's obviously a highly requested feature, but it takes some work. Okay. Let's go back to the WinForms folder. One thing that's new in Preview 5 is the single file publish. So we have the .NET publish command, which prepares the application for publishing. We can specify a runtime, let's say x86, and we can set publish single file flag to true. What this will do is it will wrap up all your binaries into one single file, and this includes the .NET Core framework as well. So this is a self-contained application, all in one file. So if I take a look at the bin folder, this is WPF1, WinForms, bin, x86, publish, here it is. This is a self-extracting archive. And if I start it, it extracts in the background. It's 115 megabytes. This is an empty WinForms application. It's 115 megabytes big. So the .NET Core framework is in there. That's why it's so big. But it just launches. It's a single file. You can copy this over to any computer in your company, and your application will just run. No need to install anything. No need to make sure that all the DLLs are at the place they're supposed to be. Just one simple self-extracting archive that runs your application. Okay, let's go to this one. I just talked to you about XAML islands during the slides. I'm going to show you this in action. Now what I have here is a WinForms application, which is written by one of my former colleagues, Wesley, who is doing a talk tomorrow about chaos engineering, so definitely go to that talk as well. This app came into existence in the big Post-it battle of 2011. So our Java colleagues challenged us for doing Post-it battles, and we wanted to be better than them, so we wrote an application. What it does, it allows you to select an image, and it pixelizes it. So you can just take Post-its in different colors and recreate the image. That's all it does. Now, for demo purposes, I've added an extra field here. And this form contains the default WinForms web view. Default web browser control that's been in WinForms since ages. And now, as you can see, as soon as it opens, it navigates to whatismybrowser.com, a website that just gives you the browser and the operating system that you're running on. And as soon as I open it, I get JavaScript errors. There's a bunch of stuff going on. And if I zoom in a bit, it tells me that I'm running IE 11 on Windows 8. Now I'm pretty confident that I'm running on Windows 10. So this is just the good old IE 11 based WebView control. That's just too old for now. And this is something we can easily fix by using XAML islands. So just so you know, this is not .NET Core yet. The talk is about the future of .NET desktop development. XAML Islands is not .NET Core exclusive, but it is a big important part of the future of desktop applications. So first thing I need to do is go into my properties of my app, and notice I'm running on .NET Framework 4. XAML Islands requires .NET 4.5 or higher. So I'm going to jump to 4.7.2, latest and greatest. There we go, make sure it still builds. Build succeeded, awesome. Now, if you want to do XAML Islands from scratch, it's kind of involved. There's a lot of bits and pieces that you need to do. Luckily, there's something called the Windows Community Toolkit. People who've done UWP might have run into it. It's a pretty amazing toolkit, all community powered. And they actually wrote wrappers around the most common UWP controls to use with XAML Islands, and the WebView is one of them. So if I look here for the Microsoft Toolkit Forms UI controls WebView, I can add it to my project. Okay, I accept. There we go. I can go into my form. I can delete the good old web control. Now in my toolbox, I get an extra entry, and this has the WebView control coming from the NuGet package I just installed. Drag it into the form. Of course, I need to change some codes because WebView control doesn't exist anymore. I can change this with WebView1.source. Let's launch this. Build errors. Must use package reference. Right. Why didn't I switch this over? You know what? Let's continue first with the port to .NET Core, because then it automatically switches to package reference, and you'll see this working. Problem here is that it's still required, or that it's still using package config, but XAML Islands requires using the new package reference type, so that all your NuGet packages are in the CS prosh file. This will happen automatically once we've ported over. So I'll show you the rest of the demo then. Let's go back to the slides for now. So what's the current status of .NET Core 3? Preview 5 was released at Build last week, like I've mentioned. It will be generally available in September 2019, so that's only a few months from now. Not a lot of time. Let's hope they get the editor in there by release, but they made no promises on that. So it might be possible that the very first version of .NET Core 3 that is publicly available will not have the WinForms or WPF editor in it. We'll have to wait and see. .NET 5 will be released in November 2020. That's next year. Now, building and debugging Visual Studio 2019, I've shown you this. They ask you to use the preview channel, or you can just manually enable preview support. And no designer support, like we've mentioned. This is the timeline they've released. So .NET Core 3 release will be in September. 3.0 will be the long-term release, and that will be November 2019. So that will be a minor version. And then the plan is to release a new version on a yearly basis. And the numbered releases will be the long-term support versions. The reason that they're doing this is so that they can have a predictable release schedule, not only for them, but also for the customers. So you know when to expect a new version of .NET to be available. Now, how do you migrate an existing application to .NET Core 3? There are a few steps, and it's actually pretty simple. It might look like a lot of steps, but it goes pretty fast. First of all, there's a tool. It's actually a Visual Studio extension. It's called the .NET Portability Analyzer. What this does is it takes a look at all your code, all the assemblies that you're referencing, and it generates a report of it. And it tells you what API calls that you're doing that are compatible with .NET Standard, .NET Core, and full .NET, and what version. If you get green lights there, you can migrate to package reference, which is what we were missing with the WebView demo. We can update to the latest .NET Framework version, because if that update fails, you probably will not be able to make it to core. You need to fix that migration first. And then I would advise you to port over your libraries, your class libraries, to .NET Standard and not .NET Core, if possible. Because if you're going to .NET Standard, you're pretty compatible with all the platforms, all across the board. Once that's done, you can migrate your app itself. Then, of course, you run the app, and please do a full end-to-end test of every single feature in your application. Make sure, or consider it a brand new application that's never been tested before, and completely 100% test it, because there might be breaking changes. I actually have one in the demo as well. Once that's done, don't forget to port over your tests, your unit tests. They also need to be ported over to .NET Core. Right, let's take a look. So the application I'm porting over is the one I just showed you. For starters, I'm going to right-click the solution and run the Assembly Portability Analyzer. There it goes. It's analyzing my code. It's done. I can open the report. Zoom in a bit. So my main application is running on .NET 4.7.2 because I just changed it. My logging class library is running on 4.0. I'm fully compatible with .NET Core, and of course with full .NET. .NET Standard is only 51% compatible, which makes sense because this is my WinForms project, and the WinForms libraries are not compatible with .NET Standard, so it makes sense. My class library, on the other hand, is fully compatible with .NET Standard, so I can easily port that one over to Standard instead of Core. Now there's also a details tab, and if you go in there, you see every single namespace that you're calling into, and also if it's supported or not. So pretty handy report, but good news for us, we can port this application over. So the WinForms project has already been changed to the latest version. Let's do the same for the class library. Yes. There we go. Now, I'm going to start by porting the class library over to .NET Standard. And the quickest way to do this is to simply add a new project to my solution. This new project dialog of Visual Studio, I'm not a big fan of it yet. So, I guess I'm not the only one. So, here's a brand new .NET Standard class library. Let's add it to the solution. There we go. Now I open the folder in File Explorer. I go into that class library. and I copy the CSProsh file. This is the brand new library I just created. I go into my existing class library, I paste it there. Let me zoom in here a bit. I'm going to copy the name of the old project file. I'm going to rename it. Then rename this to the original name. That's it. Reload in Visual Studio, and I'm done. My class library is now a .NET Standard class library. If I go into the properties, you can see I'm running on .NET Standard 2.0. This is fully ported. Let's just make sure that it builds. It doesn't. And I keep forgetting this one. It complains about duplicate files. That's because .NET Standard doesn't use the assembly manifest anymore. But it's still in here, the assembly info. It's still in here, so it has the information double. I can just remove this file. Now the build succeeds. So we no longer need this extra library. Let's throw it away. There we go. Now to port the main application itself, we can use the same way. We add a new project to the solution. This time we need a WinForms project running on .NET Core. Let's create it. Open it in File Explorer. Copy the project file. Paste it in here. Rename the old one. Rename the new one. And reload. You get a message that they recommend to use the preview version. That's fine, I don't care. If I check the properties now, I have a .NET Core 3 project. One thing I need to do is add a reference to my class library again, because by porting it lost a reference. There we go. And if I'm not mistaken, it still works, okay. Build fails because of the assembly info again. Right. So now it complains that it can't find the toolkit anymore because of changing the project type. It no longer knows about package config, so it no longer knows about the NuGet package. So I have to add it again. Now, if you want to use the community toolkit, the XAML Island stuff and everything in .NET Core 3, you need to check the include pre-release button because the current stable release of the toolkit is not compatible with .NET Core 3 yet. So you need to take the latest preview version. Okay, accept. Build succeeded. And here's my application again, this time as a .NET Core application. It still works. Let's have a look at the web demo again, this time using XAML Islands. Same web page, I'm running Edge on Windows 10. So this is the UWP web view control using Edge running in a WinForms application. And I do promise you that this also works on full .NET. This is not .NET Core exclusive. So, I have another button here that says About. And this brings me, or should start my browser, and bring me to GitHub, to the project page of this wonderful application. Except it crashes now. This is a simple process.start, which I pass in a URL to. And in full.NET, this would just boot up the default browser of the system and navigate to the web page. This does not work anymore in .NET Core. This is one of those edge cases, and this is also why it's so important to test everything. So easy to forget about the About button. But it's also quite an easy fix. So we take new process info, process start info. We'll do this later. File name this. Use shall execute is true. And I can just put this there. Then I pass in the process start info to the process start call. And we should be good to go. There we go. So that's one of those, or just to demonstrate that there are small edge cases that might behave just a bit different on .NET Core. And this is also why .NET Core is so important. Microsoft kind of got stuck into this legacy mode where they were not able to touch certain parts of .NET because they would break everything. And that's the main reasoning behind .NET Core. This was their chance to start over, clean slate, do everything in a modern way again. So what I also have here open is the Microsoft Docs on the Community Toolkit. So the Community Toolkit documentation is part of the official Microsoft Docs repository. This is documentation for the web view control, the one I just used. But just to show you that there are some other controls in there as well, like the inking stuff. Inking in UWP is pretty powerful. We can do this everywhere now using XAML islands. Also maps, media player, and they have a Windows XAML host as well. The Windows XAML host kind of takes care of some of the boilerplate codes that you need to put your own controls in there, or other controls except for the one they've already wrapped into the toolkit. It still requires some work, but it takes care of the majority of it for you. So the documentation is pretty elaborate. Should you need to use this, you can just go through there and find everything that you need. So, while we're here, let's have a look at the project file. So one of the cooler new things is that we can just edit project files in Visual Studio now without needing to unload them first. We've all been there, needing to change a project file, need to unload the file first. So we can just do it like this. And this is all that's inside of .NET Core project file. It's pretty empty, especially compared to the old project files that we're used to. I'm going to add one more thing here. And that would be the runtime identifiers. This is just saying that my runtime for this application, it will run on Windows. It's an x86 or x64 if you want application. I'm going to need this for one of the next demos. Let's have a look at the .NET Standard project file. Kind of the same thing. And one of the nice things about .NET Standard, and not a lot of people seem to know this, but is called multi-targeting. You can have a .NET Standard library that targets multiple versions of the framework. So if I change target framework into target frameworks, add a semicolon, I can do this. This is now not only a .NET Standard 2.0 application, but it's also a .NET framework library, full .NET. I managed to do both. if I open class file now, and we have a look here, this one says Net Standard 2.0, but if I open it, I can switch it to 4.5. Now, what this dropdown does is it changes the version that the editor uses. So let's say, for example, that I have some ugly if code. So if I'm running on .NET Standards, this, else. I do this. And if. And I can just write line framework. Really simple example, but just to show you how this works. So you're all familiar with these compiler pre-directives. This kind of code gets compiled. It does not get executed at runtime. It gets executed at compile time. And the correct line of code, the one that says true, that's the one that goes into your compiled stuff. So for now, you see that this line is fully colored by the editor, and the other one is grayed out. So my editor is now using .NET Standard for its IntelliSense. If I switch this over, the top one gets grayed out, the bottom one gets activated, and we're good to go. So I can now use this class library both in .NET Core projects and full .NET projects if I want to. And if we build this and have a look at the output, here we go. If we have a look at the bin folder, well, that's a heavy bin folder. Anyway, if the bin folder would open, that would be the debug folder, obviously, and then it would have two folders, one for every target framework. So it compiles into every target framework that you specified. Okay, let's go back here. Like what you've seen so far? Getting warm up for .NET Core? A lot of enthusiasm. Awesome. So, a big part of writing desktop applications is app distribution. If I would have to take an educated guess, I would say every desktop developer in here at one point in time has used one of these, right? Yeah. You can forget about all of them, because now we have MSIX. Yet another installer. The cool thing about MSIX is it actually eliminates machine rot. And we've all experienced this. You have a machine, you install some things, you uninstall some things. It starts to run slower and slower and slower. You defrag your disk once in a while. You reboot every 5 to 6 years. But you still can't get it up to speed again, right? You know what I'm talking about? That's called machine rot. And that happens because applications, you install an application, it writes some stuff into the registry, it writes some stuff to your file system, all good and well, but then you uninstall the app, and the uninstaller forgets to clean up. So stuff gets left behind in the registry, stuff gets left behind on the file system. That stuff gets loaded every time Windows starts. So that's what causes your computer to run slowly and more slowly and until you just reinstall everything. They fix this with MSIX by virtualizing everything. Every application runs in its own environment using a virtual registry and a specific part of the file system. And if you uninstall an application that was installed through MSIX, it just deletes the virtual registry and that part of the file system or that specific folder that your application writes into. Nothing gets left behind anymore. That's a major plus. Also, pretty important is differential updates. Let's say you have a game, for example, and assets in games can grow pretty big. Your game in total is about 6 gigabytes to download and install. Now, if you would do an update to some AI logic of some, I don't know, computer-controlled characters, and you would need to do a full update every time, that would mean a 6 gigabyte download every time you make a minor update to your game. That's a lot of bandwidth, that's a lot of time. MSIX supports differential updates. It knows what's changed, and it only downloads the changes. Major difference. It can also do automatic updates, and you can compare this sort of with click once. So you can make it check for new versions at certain intervals, or you can make it check for new versions every time you launch the application. Those are your options. As for distribution, you can use the Windows Store. You can use the Store for Business. You can use a classic file share. You have a file server somewhere, just dump the application there, point MSIX to the UNC path, and you're good to go. You can even use an HTTPS endpoint. You can use Azure Web Applications to host your app, or just basically anywhere. Let's have a look at this. So, first of all, to create an MSIX, I need to add a new project to my solution. And this will be a packaging project. Windows Application Packaging Project. Next. I'll call this pixelator.installer. And now it asks me for a UWP version or a Windows 10 version. That's because MSIX requires UWP workloads to be installed in your system. So if you don't have UWP workloads SDKs installed in your system, you need to boot up the Visual Studio installer and add the workload. Okay, I'm just going to keep the default here. By the way, just to mention this, I'm running the latest update of Windows 10, the May update. So here's my installer. This will create the MSIX for me. Now all I need to do is add a reference to the applications part, select my forms project, hit OK, let it work out some magic. There we go. Now since this is UWP, you get access to a manifest where you can set some assets like the icon, store icon, and everything. I'm going to use the default square with the cross in it. Love that one. You can add some capabilities to it, but you can also use content URIs, meaning that you can use protocol launchers. If you have something, // whatever, it can boot up your WinForms app if you install it through MSIX. Okay, let's build it. And it fails because it needs a newer version. And this is because we're using the community toolkit with the XAML Island stuff. XAML Islands is only supported in the latest May update of Windows 10. So our MSIX installer needs to have that version. And the target version is set to it. That's the dialog we just got when adding the project. So the target version is correct, but the min version is set to an older one. So if we upgrade this and build, now it succeeds. Now, if you want to create an installable package from this, you need to right-click the installer project and go to the store option. Now, this is really bad naming on Microsoft's side because we're not shipping to the store. I want to sideload my application. But I do need to go through the store option in the menu. And here I have the option to create an app package. And this wizard starts. Now, if you have ever done UWP development, this wizard will look very familiar to you. The bottom option is the one I need. I want to create a package for sideloading. And I can enable automatic updates right here by checking the checkbox, which is checked by default. Next. I can set a version here, and I can select which architecture I want to build for or package for. Next. And this part is about the updates. So when do I want my application to check for a new version? Every time it launches, or every few days, weeks, hours? So I'm going to go for every time it runs. I do need to point the wizard now to where I store my install packages. So my awesome share. This one doesn't exist, just for the record. Completely made this up, spur of the moment. Now it's building my application again, it's packaging everything up. It's pulling in the .NET framework because this is a self-contained application. So if we give it a minute or so, it should give us hopefully a successful output with a folder where I installed into. Now, and I will show you this in a minute. The install file that we're getting is basically a zip file. So we can open this up in any zip manager and just dig into and see what's in there. There we go, build succeeded. We have an output location. Let Explorer crash first, why not? Here we go. So this is what it created for me. I have an app installer file, and this is basically an unversioned package of your app. This is as close to click once as you'll ever get. Now into the folder itself, there's an MSIX bundle, and this is what we need. Now, there's a certificate here as well, and your machines that you install this application on need to trust this certificate, or else the installation will fail. Now, this is a development certificate generated by Visual Studio. It's not really useful for anything else but debugging. So I'm just going to dive into the MSIX bundle, open it with 7-zip. There we go. As I've mentioned, this is a basic zip file. Here's the actual MSIX file. If we dig into that one, here's my application, including full .NET Core. And here's my exe. Oh. So here's my executable, and here's my class library. So everything is in there, fully self-contained application. Now, what you also get is an HTML file. If you open this, you get an app that, or page that's pretty similar to how the Microsoft Store looks. If you ever got onto a web version of it. There's even an install button. If I click Get the App, it will launch the MSIX installer and it will fail. Cannot open app package. And this is because the UNC path I entered during creation of the MSIX, during the creation of the package, that doesn't exist. So by clicking Get the App, it tries to contact the file share and tries to pull the latest version of the app from there. Since that doesn't exist, it fails, and I can't go any further. Should you want to install this version, best thing you can do is run the PowerShell script that's in here. If you run that, it will ask you to change some execution policies. It will install the certificates. Yes, I want to continue. Certificate was installed. It's installing the application now. Now, if you ever want to ship your app, just make sure you have a valid certificate, one that's trusted by all the machines that you're installing into. You won't have to do this. There we have it. So if you take a look at my start menu now, the Pixelator installer is right here. Open it up. And here's my application running in all its glory. So I only have a few minutes left. Just want to leave you with some takeaways. So as you've all hoped by taking away from this talk, desktop development is here to stay. It's a very important part of Microsoft once more. And then you see this story coming together right now. So for the moment, you have like 3 available targets for desktop development. You have WinForms, WPF, UWP, and they're converging everything. They're enabling us to use all the modern UWP stuff in WinForms WPF. And if I would have to make a prediction, I would say that they're going to keep converging. I don't know where it will end, but I'm pretty certain that we will get to see some cool stuff in the near future. .NET Core is the way forward. So full .NET framework will end at 4.8. It will remain supported for a very long time, so it's definitely still a viable option. But from .NET 5 forward, it's .NET Core all the way. Every single new desktop application that you start should be a .NET Core application, if possible. Existing apps that are still being developed, you should consider migrating to .NET Core. And if your application is ready and you want to go distribute everything, consider MSIX for installing everything. Because it brings a lot of cool stuff. It makes sure that your machine stays in good shape. And finally, I'm going to leave you with some resources. The DevBlogs link is .NET Core 3, what's new in there, what it brings for desktop applications. Basically a summary of what I just talked to you about for the past hour. The second one, the docs, that's the official documentation on .NET Core 3. And then finally, this is the link to the blog of Oren Novotny. Oren has been really active in blogging about .NET Core 3, doing some cool stuff with it. He helped me out developing this talk as well. So least I could do is link to his blog. And with that, I'm just about out of time. So I would suggest that we leave the questions for the discussion zone. And I hope to see some of you there. Thank you very much.